Welcome to another segment of Ben's Ghost Hunters. Today we're looking for the ghost of j.j.Thomson, born 1856, died 1940. Man credited with the discovery of the electron.
What's an electron?
What? You don't know what an electron is? Well, I'll have the expert over here tell you.
This is an atom. It has a nucleus and electrons surrounding it. They are negatively charged particles.
Hear that? An electrically charged particle surrounding the nucleus of an atom. Now I've got that out of the way. Any more questions? No? Okay. Now we're going to search for the ghost of j.j.Thomson. j.j.Thomson, appear to us. Apparently he is being stubborn. So you know what, babe? If we say factual evidence about him, he'll appear. Come on, follow me. Most people believed the atom around this time was nothing more than just a big dense space. Well, j.j.Thomson proved them wrong. This is what most people thought the atom looked like. j.j.Thomson was a man known for in his life to be experimenting with something called a cathode ray.
What's a cathode ray?
What? Yeah, I said no more questions. You know what? The expert over here is going to tell you what it is. It's glowing. Well, apparently our expert is a little stupid right now, so I'll explain myself. A cathode ray is a glass tube with wires on both ends, and when you pump down most of the air and shine an electric current through it, it glows beautifully.
Gasp! Yeah, that's what I said! It glows!
Shut up, expert! What could these cathode rays be? Sometimes scientists believed that it was ether, the energy used to carry light through space. Well, others believed it was tiny bits of matter. Which could it be?
Dun dun dun!
No one knew what these mysterious rays were. When scientists put a magnet up to it, it either bent the light away or towards it, depending on which pole it was at. But when they did with the electric current, it did nothing. These mysterious rays puzzled scientists for years, until j.j.Thomson put himself up to the task. j.j.Thomson made 3 experiments with the cathode ray. Not 2, not 4, but 3.
Why are you talking like that?
Why? Because I'm on TV, and that is how we talk. Now back to the subject at hand. j.j.Thomson in 1897 set up his own cathode ray tube. With it, he was going to test to see if the cathode rays and the electric charge were all one, or if he could separate them. So what he did was, he set up an electrometer at the very end of the tube. When he shot a cathode ray through, it registered a charge. But when he bent the light away with the magnet, there was no charge, which meant the cathode rays and the light were all mixed together in one. I have a picture here of what a cathode ray looked like. You know what? I've been talking for a while. Let's let the expert say something.
Am I getting paid for this crap?
No, you're not. Now shut up!
Aww.
For a second experiment, he tried to test the effect of an electric field on the cathode rays. Other scientists tried this over the years, but all have failed. But j.j.Thomson was smarter than that. You hear that, ghost? I'm complimenting you. Now what he did, he pumped out even more air from the cathode tube. And in doing so, when he passed the cathode ray through and hit it with an electric field, it diverted the ray. Isn't that awesome?
Holy crap!
Shut up, expert. Here is a drawing of what the second experiment looked like. For his third experiment, he tried to find the actual properties of these particles. He couldn't measure them directly, but he was able to find how much they were diverted by the magnet and the charge they carried. Using this, he found the mass-to-charge ratio. After several experiments, he was able to figure out that the mass-to-charge ratio of this beam was over 1,000 times smaller than that of a hydrogen atom.
Wow.
Shut up!
Why do you keep telling me to shut up?
Because you're not a very good expert. What am I paying you for?
You're not paying me.
Oh, yeah.
With all this experimentation, he was able to come to 3 conclusions. 1, that these cathode rays are actually little tiny charged particles, what he called corpuscles, later called electrons. 2nd, that these electrons are actually parts of atoms. And 3rd, that these electrons are actually only those parts of the atom, which was later disproved by Rutherford, but we're not going to get into that. Oh jeez! His ghost is coming! It's right there!
Would anything at first sight seem more impractical than a body which is so small that its mass is an insignificant fraction of the mass of an atom of hydrogen, which itself is so small that a crowd of these atoms, equal in number to the population of the whole world, would be too small to have been detected by any means
Scary stuff. Thank you, j.j.Thomson. You have made my show a hit. But you know, what's good is talking about j.j.Thomson without talking about his version of the atom. He can clip out the plum pudding model, which is basically the electrons, or plums, are in a dense positive space, or the pudding. Unfortunately, I did not have any plums or pudding on me, so I made this instead. It is a jello mold filled with lifesavers. The darker parts, which are the lifesavers, are the electrons, and the jello is the positive space in which they exist. This concludes this episode of Ben Ghost Hunters. We have seen many things. We talked to j.j.Thomson's ghost. We learned about him, and we saw a jello atom. So, Expert, do you have any last minute things to say?
Expert, stop being my atom.
But it's delicious.
Now that the epic video is over, it is now time for outtakes.
Shut up, Expert.
No one knew what these rays were. Perhaps they were little bits of energy used to damn it! No one knew what these rays were. Perhaps they were bits of energy used to Too late.
Stupid train.
For a second experiment, he tried to test the effect of an electric field on the cathode rays. Other tries to... j.j.Thomson... Oh! No, that wasn't fake.